Welcome to this explainer. Today, we're diving straight into a really fascinating and honestly pretty eye-opening document, the Send.Win 2026 Browser Isolation Guide. We're going to solve the cyber mystery of how you are being tracked online right at this very second, completely without your knowledge and without a single traditional cookie being saved to your computer. So if you think you're safe just because you clear your browser history, well, forget it. The rules of the game have completely changed.
Okay, here's our quick roadmap for today. We're going to cover the invisible online tracker, anatomy of a fingerprint, how unique are you, cookies versus fingerprinting, who is watching you, and finally, how to protect yourself.
Section 1. The invisible online tracker. Let's start by tackling the biggest misconception about online privacy today. So, does incognito mode actually stop trackers? Look, if you're one of the millions of people who pop open a private browsing window to buy a gift or research something sensitive, thinking you're completely off the grid, well, the source material we're looking at today is about to totally shatter that assumption. And here is our invisible culprit, browser fingerprinting. Unlike the traditional cookies you're probably used to, which physically drop a file onto your hard drive, fingerprinting is entirely different. It doesn't need to save anything at all to follow you around. Instead, it just quietly observes your device's inherent, built-in properties. And because this tracking is just naturally baked into how your browser communicates to load a web page in the first place, using incognito mode or clearing your cache does absolutely nothing. It persists no matter what.
Moving on to Part 2, Anatomy of a Fingerprint. This is where it gets super interesting. Let's see how these trackers actually build a profile on you.
Think of it like a police sketch artist layering features to draw a face. Websites silently collect these totally basic parameters the literal millisecond you visit their page. They ask your browser, hey, what operating system are you on? What's your screen resolution? What time zone? Are you plugged into the wall or on battery power? What language is your keyboard using? Now, on their own, none of these clues are a big deal, but layered together, the picture starts getting very, very clear.
Now let's look at a much more complex clue. It's called canvas fingerprinting, and this is wild. A website runs a script that basically forces your browser to draw a hidden, invisible image in the background. Your graphics card, or GPU, processes that image. But here's the catch. Because of microscopic, practically atomic manufacturing differences in your specific GPU hardware and your drivers, your physical computer is going to render that image ever so slightly differently at the pixel level than mine will. The tracker then takes that specific rendering and converts it into a highly unique tracking hash. It's literally an unavoidable identifying marker.
And they don't stop at images. Trackers also map out your specific graphics card vendor using WebGL. They even use the Audio Context API to send a silent audio signal just to measure exactly how your unique sound card processes frequencies. They'll even check the exact specific list of fonts you have installed. Put all that together, and it creates a digital signature that is virtually unspoofable.
Part 3. How unique are you? So, the big question is, mathematically speaking, how unique is your specific setup? Can they really pick you out of a crowd?
Well, the guide answers this using entropy analysis. In data science, you only need 33 bits of identifying information, or entropy, to uniquely identify every single human being on planet Earth. Think about that for a second. Just 33 bits to pick you out of 8 billion people.
And shockingly, when you combine your canvas fingerprint, your fonts, your time zone, and all those other clues, your browser's total entropy typically leaks up to 60 bits of data. So, mathematically, you're leaking almost double what it takes to make you effectively totally unique on the internet.
If you need hard proof of this, the Electronic Frontier Foundation actually ran the numbers. They found that an overwhelming majority of browsers have a totally unique fingerprint. As long as you have JavaScript enabled, which, let's be real, you do because the modern internet breaks without it, the uniqueness rate is a staggering 94.2%. You basically have no crowd to hide in. You're essentially standing alone in an empty room under a giant spotlight.
Section 4. Cookies versus fingerprinting. Let's shift gears and compare this to the old-school tracking we're all used to.
Seeing them side by side really highlights why fingerprinting is such a game changer. A cookie lives on your device. That means you own it. You can easily delete it. But fingerprinting, that math is computed entirely on the server side. It completely bypasses your ability to clear your data. And the real kicker here is consent. While cookies trigger those annoying GDPR pop-ups everywhere you go, fingerprinting is often just happening quietly in the background, entirely without your permission.
Part 5. Who is watching you? You're probably wondering, who exactly is deploying this tech in 2026?
Honestly, the list is huge. Ad networks have totally embraced fingerprinting as their main cross-site tracker now. But it's not just marketers. Banks use it heavily for fraud prevention. If someone logs into your bank but their browser fingerprint doesn't match your usual laptop, it triggers an alarm. And the big guys like Facebook, Amazon, and Google, they rely on this heavily to catch users secretly running multiple accounts from the exact same physical device.
Finally, part 6, how to protect yourself. Okay, let's talk solutions. How do you actually don a digital disguise?
First things first, we gotta bust a massive myth. A VPN is not a magic shield here. Yes, a VPN does a great job hiding your IP address and encrypting your traffic, but it does absolutely nothing to change your hardware fingerprint. Websites can still see your exact canvas rendering, your WebGL data, your specific fonts. They know exactly who you are. They just think you happen to be sitting in a coffee shop in Switzerland today.
So what actually works? Well, the source notes that standard anti-tracking extensions usually fail. Why? Because the very act of blocking a tracker can actually become your fingerprint. If you're the only user out of a million outright blocking a canvas request, boom, you stand out. It completely backfires. Strict modes on regular browsers often just break websites. Tor is secure, sure, but it's famously slow. Brave is great for everyday use, but it won't let you run completely isolated, separate identities. And that leads us to the heavy hitter, the antidetect browser.
The guide points directly to cloud-based anti-detect platforms like Sendwin. Instead of playing whack-a-mole trying to block scripts, Sendwin runs your sessions in sandboxed cloud environments. So every time you spin up a new profile, it's physically running on completely different server hardware. It's essentially like someone handing you a brand new, clean laptop straight out of the box for every single tab you open. Websites don't see your computer. They see a completely different, naturally generated hardware profile every time.
So as we wrap up this explainer, we're left with a pretty wild thought. Right now, at this exact moment, your device is broadcasting a highly detailed portrait of you, leaving an invisible trail of breadcrumbs with every single click. Now that you understand the anatomy of a browser fingerprint, you really have to ask yourself, what clues is your device leaking today? And more importantly, what are you going to do about it?